Okay. Hello, Fujii-san. Can you start with your share screen for testing? Yeah, yeah. Or from me. I think it's easy from you. Okay.
Can you show?
Yeah, I can see.
Can you
Yeah.
see? Okay.
Yeah, yeah. Kenapa? 40. I think it's hari ini kan studentnya. Kalau yang internasional hari ini studentnya udah cukup ya, Mas Chandra ya? 29.
Yeah, yeah.
Oh, yeah, yeah.
Yeah.
I think because of this Monday, the student is only about 25 something, yeah. And but we record this class because of we have another class on Wednesday and also Thursday. The total student is more than maybe around 200, yeah. Yeah.
Yes, yes.
Yeah, yeah. Yeah, but if you don't mind, let us to record your class. Is it okay? I would like to record the class, yeah, and make it like video YouTube, and we will share the class.
Record. I see. Yeah. Okay. Okay.
Okay.
Yeah. So can I start?
Yeah.
Or...
Can you record this class because of
yes,
you want
I
to
have.
change? Yeah. Okay. It's already. Yeah.
So can I start or?
Okay. Yeah.
Okay.
Yeah,
thank you very
okay.
much.
Okay.
So, okay. Good morning, everyone. So my name is Minoru Fujii. I'm working for National Institute for Environmental Studies, Japan. So today I'd like to explain a bit about some joint research with ITB and NIS and also the Ministry of Industry in Indonesia. So the target is about so how to utilize plastic waste efficiently, correctly, and get the maximum energy from the low-grade plastic waste. Also to reduce the amount of waste which is going to the landfill site and so on. So, but today, before going to the detail of that joint research of us, so I'd like to a bit explain about the NIS, my institute, and then I'd like to introduce some background information about the energy saving technologies. Also, then I explain a bit about our joint project. So first, very briefly, I'd like to explain our institute. So National Institute for Environmental Studies, all the researchers studying about environment, and we cover so many wide areas of environment, for instance, low carbon issues, sustainable material cycles, also harmonization with nature and health and environmental safety. And I mean, in this program, so environment, economy, society, integration, and also some environmental recovery and environmental innovation, and so environmental emergency management as a current topic after the big earthquake about 10 years ago. So, and total permanent staffs, researchers are like 230, and also total 300 permanent workers are here. Also, we have contract staff, including postdoc researchers and assistants and so on. So in total, around 1,000 people are working in my institute. And this is a history of NIES. So first, we established in 1971. At that time in Japan, the air pollution and also water pollution was severe. So that's why our institute was established. At that time, the main topic is how to solve such air pollution and water pollutions. But nowadays, it's almost okay in those two two environmental issues. Almost solved. But of course, partially it's also it's still a problem, but almost okay now. So now new environmental issues coming, for instance, as you know, the global warming issues and some chemical substance, also some biodiversity. Now such new topics are the main target of our institute. So that is a very brief background. And then I'd like to explain a bit about the low carbon technologies or related to some technologies, because today's topic is I would like to utilize the low grade plastic waste as an energy source for industries. So it's very much related to the energy issues. So first, this graph, this slide shows some three major countermeasures, three types of countermeasures to reduce CO2 emission toward decarbonized society. The first thing is, yeah, we need to utilize more renewable or some wastes as an energy source instead of the fossil fuels. For instance, yeah, waste is one of such resources. Also, biomass. Also, some zero emission power like wind turbine on the, well, solar panels. So in Japan, maybe the as in Indonesia as well, I think the amount of waste is a bit limited. Also, biomass is not, we don't have so many biomass because we need to preserve the forest for ecosystems. So considering such situation, maybe we need to use more solar energies. That is the situation. But to utilize this fluctuating energy, we need to consider to use more batteries, or maybe we can consider to use heat storage. That is the situation. Also, we need to improve the efficiency of energy when we utilize the energies. So, for instance, yeah, insulation technology is also is important to reduce energy for cooling or heating of the space. Also, we need to consider the heat recovery from the exhaust of the when we ventilate the room. Also, some optimum operation using recent some information technologies is also effective to how can I stabilize the energy consumption space. Also, today I will explain later, heat pump technologies are very important. Uh, yeah, maybe in Indonesia, you don't need to utilize space heating, so you will not think about this so much. But anyway, to cool the room, heat pump is inevitable. Also, to heat for space heating, it also works very much. I will explain a bit later. Also, the third option is some maybe supplementary option. So carbon sequestration is the one important technology. So yeah, it's better to reduce the energy consumption efficiently by improving the energy efficiency. Also, we need to utilize more renewable energies, and as a result, we need to reduce the consumption of fossil fuels. But it's not so easy, so we need to rely on fossil fuels for such period. We will release CO2, but that could be stored in very wood material. Also, if it is difficult, separate the CO2 from the flue gas, and maybe we can store it underground or under the ocean. That is the story. But this cost I escape this kind of technology, but maybe rely on some extent. That is the situation, I think. And I'd like to explain a bit about the mechanism of power generation because it's related to the today's topic as well. So maybe I'm also sure you may already know very well, but anyway, so I'd like to explain the mechanism very roughly. So thermal power generation is, yeah, as you know that first we incinerate, combust some fossil fuels like gas, oil or coal and heat up the water, and it becomes a steam with high pressure and high temperatures. But if we have only such high pressurized steam is not enough to rotate the turbine. So we need the flow of the steam to rotate the turbine. So to make such a flow, we need to condense the steam here. So this means when we condense the steam, we need to cool down the steam, which means some part of the heat will be lost here. So, but yeah, air becomes water here, so there is a huge flow of the steam here, so we can rotate the turbine, and as a result, we can generate electricity using the generators. So anyway, in the thermal power plant, we need to lose some part of the energy, heat. That is a very big weak point of the thermal power plant. But anyway, it's inevitable. It's the how can I say the law of the it's regulated by the law of thermodynamics. And this is a more a bit how can I say the diagram of the picture of the uh, power generation system. So anyway, that system has a bit complicated. So some steam is not, how can I say, simply go through the turbine, which is, for instance, yeah, some part of steam is around the turbine many times. So or several times. So from the, for instance, middle of the turbine, we can extract the steam. As I mentioned, yeah, we need to lose some part of heat. Yeah, if we use seawater to cool down the steam, that we can get only slightly warmer seawater at that time. But the way to lose heat is some other options, which, yeah, maybe some part of steam after the, for instance, pressure turbine, we can still have the some pressure and temperature steam. That steam could be utilized for industrial processes, and still it works to make the flow of the steam. So yeah, of course, yeah, in the case to utilize the seawater to cool down the steam, the power generation efficiency becomes a bit lower, but still it can generate. And that's a bit low temperature and low pressure steam still you can be utilized in industrial processes. So this is some real example of the steam extracted steam utilization in Japan. So that is sorry, it's almost written in Japanese in this map. Anyway, here this is Kawasaki Thermal Power Station. It's a very advanced type, very efficient gas-fired power plant. So its power generation efficiency exceeds 60%. Only less than 40% becomes heat. But from this power plant, it's not so big amount, but some amount of steam is extracted from the some middle of the turbine. So and that steam is supplied to neighboring 10 factories. Almost they are the chemical factories. They utilize steam for their production processes. As a result, they can save. Originally, they consume fossil fuels like natural gas to supply steam for their production processes, but they if they can get the steam from the power plant, they can reduce the amount of fossil fuel consumption for their production. So as a result, they can save the fuel for, it's not so big amount, 20,000 kiloliter per year, and the resulting CO2 reduction effect is like 46. For towards low carbon society or decarbonized society is heat pump technology. So yeah, anyway, as I mentioned, for the cooling, we need to utilize heat pump technologies, but it could be utilized for heating. That is a very important point. So anyway, the heat pump technology is pump up the heat. It's like the case of water pump. Water pump, you pump up the water using the energy of electricity. But here, this facility pump up the heat from the low temperature heat area to the higher temperature space. So you know that if the air is compressed, that temperature increase. So here is the compressor, and using some part of some electricity that can compress the air, and that resulting high temperature heat can give the heat to the high temperature room area. And then you know that the after the if the compressed air expands, that temperature decrease. So here we can get cool air here. So we can repeat this cycle. So here the for the low temperature air that can absorb heat, and then after the compression that can give the heat here. So that is the mechanism of the heat pump technology. So the fundamental difference from the just gas boiler is gas boiler only can supply heat, which is included in the, for instance, the gas. But in this case, if we put one unit of energy here, for instance, in this case, we can get 6 times more, 6 times as much as heat here. So, which is much more efficient. Yeah. Of course, currently we need to rely on the thermal power plant to get electricity. That efficiency is around 50%. So to generate 1 unit of electricity, we lose 50% of energy. But still, if we can get 6 times more, 6 times heat here, so in total 50% and 600%, total 300 percent of heat we can get. So anyway, we can save so much fossil fuels. That is a good point of heat pump technologies. So also it works using the electricity is good because yeah, if we rely more on renewable energies like PV, so that system can directly utilize that uh, electricity generated by solar panels. So also for the air conditioning or the maybe hot water supply for the residential areas or the commercial buildings, that heat could be easily stored in a tank. So for instance, in the case of solar panels, only the daytime we can generate electricity, but during the daytime, that heat pump can make some cool water or maybe hot water, and it could be storage for instance, if we want to utilize hot water at night to take in shower, that stored hot water could be utilized. So maybe in the future, we can rely on only the renewable energies if we can utilize the heat pump technology efficiently. That is a very good point. And as I explained about the power generation, thermal power generation, and heat pump technologies, they are apparently it's very different technologies, but actually they are just the, how can I say, opposite cycle as thermodynamics energy cycles like Carnot cycle. So yeah, in the case of power generation, thermal power generation, they utilize high temperature heat, and when they some of the heat is lost here, but during the process they can extract some work. So work means here maybe electricity is a kind of work. So and that efficiency is expressed by this equation. So 1 minus temperature, low temperature divided by high temperature. So in the case of thermal power generation, so it's better to, yeah, for instance, yeah, if the temperature of the steam or mass or combusted gas in the case of gas turbine, then anyway, the temperature is higher, we can get, you can easily understand from the equation. So we can get more higher efficiency of power generation. Also, temperatures, low temperature is much better to be more low temperature, but a steam extraction, yeah, increase the temperature. So it's affect to reduce the efficiency of power generation, but that extracted steam could be utilized to reduce the fossil fuel consumption in the nearby factories. That, yeah, overall it works to reduce the fossil fuel consumption and so on. So that is the situation. Also, heat pump, that is, yeah, using electricity here, they from the low temperature heat to higher temperature heat storage, they can remove the heat. So that efficiency is just opposite of the power generation. So it's so-called COP, coefficient of performance. That is, yeah, maybe you can easily calculate this way. So, and in the case of heat pump, yeah, so COP means using the one unit of electricity, how many times heat could be transferred. That is the COP means. So larger COP means higher efficiency. So to increase the number of this COP, so for instance, TH minus TL should be smaller, which means if the temperature difference here is higher, so the efficiency of COP becomes low. But if the temperature difference is not so large, that COP could be very big, very efficient. So that's why, yeah, in the case of, yeah, hot water supply or just cooling of the room, in that case, temperature difference is usually not so high. It's several 10 degrees Celsius and so on. But for instance, in the case of steam supply, yeah, like 200 degrees Celsius, in that case, temperature difference is very high. So for such purpose to supply steam for the factories, heat pump is a bit difficult to be applied. Yeah, still, yeah, using how, for instance, if we have waste heat like 80 degrees Celsius, that heat pump can supply, for instance, to 120 degrees Celsius steam. That is possible, but still, the such heat pump is very expensive. Also, the, how can I say, the amount of the heat that heat pump can supply at one time is a bit limited. So still the heat pump of utilization of heat pumps in factories for the production process is a bit limited. So that is a challenging. But for such steam, we can utilize the energy of waste. That is our idea here. We are proposing to proposing with in collaboration with NIS ITB and the Ministry of Industry. So this is this graph shows the exergy ratio. So maybe so exergy is some indicator to show the quality of energy. So electricity is perfect energy, so whose exergy ratio is 100%, which means in theory all the electricity could be converted to any type of energies like maybe sound, so also you can move something, also some light and so on. So in theory, it can be converted to any type of energy without any loss. That is the uh, situation of electricity. Yeah, actually, of course, there are so many losses. It's difficult to, for instance, convert all the electricity into light. But anyway, in theory, it's possible. And also, fossil fuels are also the very efficient, high quality energy. So whose exergy ratio is like over 90 or 95%. And in the case of heat, maybe you can easily understand. For instance, if you can imagine the, I guess, some uh, pool, a bit warm pool, uh, and that may have in the maybe pool, swimming pool. Maybe by in Indonesia, maybe you don't utilize the, how can I say, um, you don't warm up the swimming pool's water, maybe it's a bit difficult. Anyway, okay. So in the case of a big hot spring, big bath. So in the bath hot spring, there are huge amount of heat in the total as a quantity. So, but that temperature is slightly warmer than the temperature of the environment. So the total amount of heat energy is large, but quality is very low. Maybe here it's 20 degrees Celsius. If the temperature of the big hot spring is 40 degrees Celsius, that exergy is like 3 to 4%. So that so maybe you can easily understand such slightly warmer water cannot be converted into any other types of energy. So it's difficult to generate electricity using such low temperature heat. Also, it's difficult to move something using such low temperature heat. So that's why that energy is, its exchange ratio is low. But then steam, which is utilized in industrial processes, that exchange ratio is still not so high. So it's in the case of 100, maybe 70, 80 degrees Celsius, that exchange ratio is about 20%. So which means, yeah, as I mentioned, so it's difficult to apply heat pump technology for high temperature heat supply. But so they need to utilize, for instance, boiler to provide steam, but just convert fossil fuel into this steam, we will use almost 80% of exergy. So that is a big loss of the energy. So, but it's a bit difficult. Yeah, we don't have alternative technologies about efficiently provide steam of those temperature areas. So, but yeah, insulation plant, waste insulation plant that can provide this 200 degrees Celsius steam easily. So if we can provide that steam from waste injection plant instead of provide steam from the gas boilers, we can save much fossil fuels very efficiently. That is the idea. And this is some photos, maybe it's some picture of the waste, typical waste incineration plant. in Indonesia, you don't have so many, maybe very limited number of incineration plants there, I think, in Indonesia. But in Japan, we have so many waste incineration plants, over at least 1,000 incineration plants all over the country. And this is typical stalker type furnace. And here we put waste and combust it here. And many of the advanced type English initiation plant have the boiler to recover heat. And maybe in many cases in Japan, we generate electricity using the steam. But problem is power generation efficiency of the thermal power, the waste initiation plant is very low because yeah, this combustion gas contains very harmful gases to the wall of the boilers, which can collapse the wall of the boiler, especially the so-called parts superheater. As we explained, if we increase the temperature of steam, we can expect more higher power generation efficiency. But to prevent the corruption of the boiler tubes, they cannot increase the temperature of the boiler here. So that's why the generation efficiency is limited around 20, at the maximum around 20 to 25%. And in average in Japan, the average power generation efficiency of the thermal power plant is only around 12%, 12, 1, 2%. That's the situation. Also, in China, this is it's very big initiation plant. I visited last year. I visited Shanghai, and this is very big initiation plant. Its the capacity is 6,000 ton per day. Yeah, in Japan, maybe our maximum size is like 1,500 ton per day. So it's 4 times larger than Japanese largest incineration plants. Anyway, in China, they nowadays they constructed so many incineration plants. But unfortunately, in Japan, also in China, also their way to utilize energy is only power generation. So and that power generation efficiency is not so high. Yeah, you can understand this efficiency is not so good because, for instance, in the case of coal-fired power plant nowadays, that efficiency over 40%. Also, in the case of gas-fired power plant, as I already mentioned, it's over sometimes 60%. So compared to such thermal power plants, this efficiency is not so good. So currently, yeah, this those figures shows that y-axis shows previous activity, the quality of energy. And now, for instance, we utilize the heat recovered from waste incineration and to generate electricity. But as I mentioned, that efficiency is not so good. And natural gas is utilized in the factory to just make steam. But this is not so efficient. Yeah, more efficient way is, for instance, to provide steam from the waste incineration plant. And if the gas is utilized for power generation, we can expect much higher power generation efficiency compared to the case of waste power generation. So we should try this because we can save much fossil fuels by changing from the current way of energy use to the some optimized way of energy use. So from this, I'd like to explain our collaborative research between ITB and Ministry of Industry and NIES. So the purpose is maximize environmental and climate change impact by parallel use of national material recycling and high efficient energy recovery. And so for instance, yeah, maybe nowadays anyway, that plastic waste is a very big issue in the world, also in Indonesia, in Japan as well. And once it's high-grade waste plastic like PET bottle should be recycled again and again, many times to be recycled as a material. But unfortunately, some part of um, waste is not so, I guess it's a mixture of the food waste and papers and some foreign matters like that. So it's difficult using those waste, low-grade plastic waste to produce high-quality plastic products. So for such waste, maybe it's better to consider the incineration of the waste. But if we just generate electricity at incineration plant, it's a bit, okay, the waste of the energy. So only 20% is recovered as electricity. But if we can send steam to neighboring factory like chemical factories, yeah, it's steam could be utilized to anyway produce new plastic pellet. So it's through the energy recovery, but if we can draw a kind of uh, closed loop type, how can I say, uh, resource circulation system. So that is the point. So yeah, we can save much of energy, fossil fuels. Also, we can save lots of money for such fossil fuel. Also, we can um, efficiently utilize the waste. And if we apply this kind of closed loop type energy recovery into the Indonesia, so that is this slide shows such situation. So the upper side shows that maybe the current status in Indonesia. Maybe it's one-way production, consumption, and yeah, some part of waste is collected. Some part of recyclable plastic waste is collected, maybe at the dumping site by the human manually, and uh, but maybe half of the plastic waste, as I mentioned before, the low-grade plastic waste is not collected and remains there. And maybe after some heavy rain, some part of the plastic waste may go into the rivers, and also together with some polluted water. Also in the dumping site through some fermentation processes, methane will be emitted to the atmosphere. As you know, the methane has 20 times more global uh, warming effect. So that is also the problem. So this is the situation. But if we can apply the previous idea, so anyway, this is maybe as close to the current situation. Maybe around maybe half of the high quality plastic waste is recycled again as a material. But rest of the low grade plastic waste is collected together with other combustible waste, which used to go to the dumping site, is here insulated at the incineration plant, and that produced steam is supplied to the chemical factory, for instance. So through the efficient use as an energy source, we can save maybe compared to the case of conventional waste generation system, we can save 2 times more CO2 emission as a total. Also, we can get 2 times more revenue from the sale profit of steam. That is a good point. So through those activities, we can maybe minimize the amount of the waste which goes to the dumping site. Only the ash is go to the landfill site. Also, maybe we can expect more clean rivers, because this low quality waste has a, how can I say, the value. So because it can be utilized as an energy source very efficiently. So as a result, we can expect the more appropriate collection of the waste. As a result, we can reduce the amount of waste which is just throw away the environment. So as a result, we can have more clean rivers. Also, finally, we can reduce the amount of plastic waste which goes to the marine. So maybe this system can contribute to multiple SDGs, I believe. And pitch graph shows, this graph shows the efficiency of different types of plastic recyclings. So the top shows some theoretical maximum efficiency of the case of material recycling. So and this X bar shows the maybe some efficiency of recycling. But it's, yeah, I'd like to compare the efficiency of material recycling, chemical recycling, and so on with the efficiency of thermal power, conventional waste power generation. So I converted the efficiency of recycling into the power generation efficiency here. So anyway, this is in proportion to the amount of fossil fuels saved by the recycling. So the maximum efficiency is here. It's like 60% of, it corresponds to the 6% of power generation efficiency. And actual efficiency of material recycling is here, those purple graph bars show. So if the quality of the collected plastic waste is good, we can expect a bit higher efficiency, but still maybe around over 40 or around 50, that is the situation. But if the quality is also good, maybe it's sometimes lower than 30%, that's the situation. And we have so-called chemical recycling, like in this case, yeah, most of the plastic waste is put into the coke oven in a steel producing plant. And yeah, plastic waste is, how can I say, becomes some part gas, some part is oil, some part becomes coke. So anyway, they are efficiently utilized. So that efficiency is not so bad. So maybe almost 40%. But for instance, in the chemical recycling, some conventional type of liquefaction. So chemical companies want to do this recycling because that liquid, the oil, actually the oil could be utilized as a raw material. So the feedstock to produce plastic again. So, but actually that efficiency is not so good. Maybe around 20 several percent or in, because yeah, it's only a part of plastic could be utilized. So we need some separation process of the plastic waste. Also to degrade the plastic into the gas or oil and so on, we need to put energy, heat. So as a total, the efficiency is not so high. That is the situation. And as I already mentioned, the power generation at the initiation plant is not so high. It's like 20 several percent. But compared to that, semi-closed loop type energy recovery, there are two ways. Maybe we can produce, here in Japan we call RPF, but in Indonesia maybe you call RDF. That is one way to utilize waste efficiently in industries. Also, after the initiation at the initiation plant, if we can send steam to the neighboring factory, that efficiency is also good. Anyway, that efficiency is about 40%. It's comparable with the efficiency of material recycling and much, much higher than the power generation, also some part type of chemical recycling. Also, this here shows the economical benefit compared to the case to just generate electricity. Maybe if we combust 100 gigajoule of waste, if generate electricity, that uh, electricity worth like 500 US dollar, but if we can substitute Vankashi oil through the supply of steam, that oil price equivalent to over 1,000 US dollars. So we can get 2 times more revenue from the efficient use of steam after the combustion waste. And as I mentioned, unfortunately, in Japan and in China as well, so we don't have so much experience to send steam from the waste incineration plant. Almost all the incineration plant only do the power generation. But in Korea, in South Korea, they have good examples. So for instance, in Ulsan Eco Industrial Park, they have so-called steam highway project. And in this project, there are two waste incineration plants. They used to generate electricity, but they construct this kind of steam pipeline to the neighboring factories. Here, in this case, they construct 300 meters pipe, and here almost 3 kilometers pipeline. And of course, they need some high initial investment to construct the steam pipeline. But as I mentioned, so they can get more profit rather than just generate electricity. So the revenue is very high. So the payback period is very short as a result. So in this case, if the distance is short, the period is like 0.4 years. And here, maybe, yeah, here, also the capacity is bigger in this case. That is another reason to here the payback period is, yeah, distance is much longer, but still the payback period is still 0.7 years. So, which means after this years, they can save much cost for the energy production. Is very rough calculation. If we construct the incineration plant in Indonesia and send steam, how many years we can get we can recover the initial investment. Yeah, in the previous case, they already have incineration plant. Just construction cost for the steam supply is here considered. But in Indonesia, you don't incineration plant, so only the limited number of incineration plant you have. So in the case of Indonesia, you need to consider from the construction stage of the incineration plant. That is a bit expensive, but benefit of the sale profit of steam is a bit higher than the case to just generate electricity. So we can save much money. So in this case, maybe the payback period is about 9 years. And also in the case to construct the 600 ton per day scale incineration plant, and that emission reduction effect is about 70,000 ton per year. So it's great amount, I think. And this 9 years is, how can I say, as a pure business, it's not so attractive. But yeah, if you think that many benefits, not only the sale profit of steam, you can solve many problems like the issues associated with the landfill of the waste. Maybe it's also, yeah, maybe if some public government can support some part of the cost for the construction, maybe it's possible, yes, I think. And also you may worrying about the insulation of the waste, but now the technology is very much advanced. Yeah, for instance, nowadays it's possible to remotely operate, or maybe even the AI can operate the initiation plant very nicely. Yeah, it's stable combustion of the waste is very important in the initiation plant. But yeah, in the case of the matured engineer operate, AI can, how can I say, more stably operate the initiation condition of the waste. That is the situation. Also, real-time monitoring of the flue gas, also the some initiation condition makes can minimize the emission of the toxic substance from the waste incineration plant. Of course, also the incineration plant has lots of equipment to prevent the emission of the toxic gas and so on. They have the filters, also they have the treatment plant of the SOx and NOx and so on. So maybe nowadays it's the incineration plant is very clean plant. So that's why in Japan we have more than 1,000 of incineration plants. So the UNEP and I just recently published this guidebook. Very small, but I contributed also to this guidebook. If you are interested in the technology of waste to energy plant, maybe please look this. And this is a case study site in Indonesia. Now we are thinking one area is Delta Mas City. Japanese trading companies now developing this area. So and another is Mushirawas area, and the also the another point area is Palembang. So anyway, they are in Delta Mas City. They are how can I say that also they, to them waste plastic issue also there are some waste issues are very important, so they want to solve the problem. Also in those areas, plastic waste issues are also the big high priority targets. So that's why we may be able to collaborate with those areas. And this map shows the area of Delta Mas. So here is big area. So total 1,000 around 300 hectares, and half of the area is for industrial area, and rest of half would be like commercial or residential areas. And maybe there are several so factories here. So like main factories are like automobile assembly company, but factories, but still they consume steam for their production process for drying, painting, also washing some parts and so on. Also, some other factories may utilize steam. So now, Sojitz, the trading companies asking those companies about the possibility to utilize steam, which will be provided by waste incineration plant. And maybe if we can find enough demand of steam, maybe we can consider to construct a incineration plant here and to construct steam pipeline and provide steam. That is any idea, but it's as you know, the recent coronavirus situation makes a bit difficult to continue the research. But anyway, maybe in the future we can check the demand of the steam. Then we can hopefully going to the feasibility study of such a idea. And those are the members of the project. Yeah, here, National Institute, our Institute. Also, Dr. Remi will give you the lecture later. His office is Remote Sensing Technology Center of Japan. Also, yeah, your ITB, also the some companies and so on. And yeah, the beginning of this year, I visited Jakarta and did some ceremony of the MOU between the Ministry of Industry and also the ITB. I'm here, and the Director General of the Ministry is here, and Uchok-san may here. So now we are collaborating to. Anyway, I'd like to make it happen in Indonesia about this kind, as I mentioned, some semi-closed loop type energy recovery and also the high quality material recycling loops in parallel. And this is the very brief overview of the project. Anyway, we will do some feasibility study about the idea semi-closed loop energy recovery, also the material recycling of the plastic waste. Also, in Indonesia, I think we need to have some analysis using the satellite data would be important because to, the previous three case study site is just the example. So maybe we expand our idea to all over the country in Indonesia. We need to find the appropriate places, how can I say that, optimum places for the project. But in Indonesia, it may not be easy to collect enough data, but from the satellite, we can get so many data. For instance, using the satellite data, we can, from the pattern of the buildings or the residential houses, we can estimate how much plastic is generated. Also, from the appearance of the factories, maybe we can guess the amount of steam demand. So, combining such information, we can find appropriate optimum places to to do this kind of project. That is our idea. Also, this is very rough calculation of the estimation of the effect when we install this kind of system. So considering the composition of the waste in Indonesia, maybe some part could be utilized as a material recycling of plastic. But rest of the combustible waste is initiated at the initiation plant. And as a result, we can reduce the amount of waste which goes to the dumping site, and also we can save methane fermentation, so methane emission from through the fermentation in the landfill site. Also, we can get much reduction effect through the substitution effect of fossil fuel here. So anyway, through the combustion of plastic, we can that emit CO2 some part, but reducing CO2 emission effect is much higher. So as a result, in total, in net, we can save this amount CO2. Sorry, this is for 100,000 people in Indonesia. So also, this is a similar calculation. So if we can have some subsidy for the first initial construction, maybe some payback period could be a bit shorter. So also in the future, we need to convert the, how can I say, the industries to be the zero carbon industries. This, I'm interested in the heat supply of the industry. Of course, they need to can I say, change their electricity to the renewable energies as well, but also they need to change their heat supply as a low carbon one, decarbonized ways. And maybe, as I mentioned first, the cogeneration type steam supply and power generation is efficient way to reduce the energy consumption, but that's just energy saving. It's a bit far from the zero carbon. So then next we need to consider the efficient use of waste containing the energy. And those two are economically also we can get benefits. So using those two countermeasures, we can change the infrastructure of the industrial estate. Then after that, but that amount is not so enough. So after that, we need to consider to introduce renewable energies like solar panels. And using the how can I say, those infrastructure, we can add step by step. We can increase the amount of energy generated by the solar panel. For instance, gradually we can change the current base energy state towards the decarbonized future ideal industries. That is the situation. And in Japan, I started some how can I say, feasibility study or project in Japan in Kitakyushu City here. Also, I have the survey in Kawasaki City as well. And also, I think the time is also limited. I like to skip this slide. Yeah, anyway, so some information system is also would be important to how can I say, have the good matching of the waste generation, also the user of steam and so on. That is the situation. And this is some ideal so symbiotic type energy system in the future. Maybe we can combine the industrial system and urban system. For instance, we can utilize a waste in generating urban areas in the industrial areas to efficiently reduce the CO2 emission from here and so on. So thank you very much for your kind attention.
Okay. Thank you very much for the presentation for the student. Sorry, Pak, can you turn it off? Yeah, yeah. Sorry. Just turn it away. Sorry
Okay.
for the disturbance. Yeah. Okay. Is there any question from the student? Hello, hello, student. Hello.
Oh, ma'am.
Oh yeah. Okay. Please, your name and is it class 0, 1, 2, or 3, regular for international or GTO?
Okay, ma'am. I am
Okay.
Heva. I'm from the international class.
Okay.
I would like to ask about the incineration plant. So I've read that incineration plant actually emits dioxin, and it has become a problem even in Japan. It is said that there is a correlation between how the plastic waste increase each year, but also the dioxin concentration in the air increase each year. Is there a mitigation plan for this kind of consequence?
Thank you very much for your question. Yeah. Anyway, in Japan, we already combust lots of plastic waste already. And yeah, as you mentioned, if improperly the plastic waste is combusted in the incineration plant, which will emit dioxin, but we control the temperature of the combustion. So first we combust higher temperature and then cool down the combusted gas rapidly. So through that control, we can minimize the generation of the dioxin, and then we will have the that experiment initiation plant has a system to capture the dioxin, so-called anyway, they have the filter to capture the dioxin. So after the combustion plastic waste, we can still, yeah, the air is very clean. So yeah, it's now so yeah. In the many years ago, it becomes a bit problem, but now no problem for such dioxin issue. Thank you for your question.
Is there any question from the other student? There are. I will provide 2 questions because of we have another presentation from Dr. Remi Chandran from Japan as well. Yeah. Apanya? Pertanyaan.
Bukan passwordnya.
Oh, okay. Yeah.
Ada passwordnya.
Yeah. Okay. Where is other student? Hello. Yeah, in my understanding, there is a strict regulation for air pollution in Japan as well in Singapore and Germany because of a practical for waste treatment, particularly for municipal solid waste, can still use incinerator, while in like Australia, countries like Australia, they do not want to use incinerator for the municipal solid waste anymore, and tend to use landfill or other process. Yeah. And is there any specific in the regulation for the component, for example, like maybe particulate must be very low, or plus maybe like dioxin, yeah, specific in dioxin, but in Indonesia only some parameter, but not specific. The way burn in industry, and there is some additional parameter for industry who burn the waste. Yeah.
So yeah,
Yeah.
yeah, I think yeah. In the case of maybe Australia, they have huge land area, so they can landfills many waste. They can have alternative choice. But in Indonesia, or especially the big cities, maybe it's difficult to find enough space.
We don't have place and space.
Yeah, so in Asian countries, we need to have different strategies. That is one point. Also, in English, I think the how can I say that? Heat value of the waste is very important point, because temperature during the combustion is very important to reduce the generation of the dioxin. So maybe if the heating value is very low, it is difficult to control the temperature. So we need to be a bit careful about that situation, I think. So maybe
mute, yeah, sorry. Usually in Indonesia, municipal solid waste dump site is far away from location of industry that we can export the product of steam directly to industry. But for electricity, yes, we can connect to the grid, PLN grid, and we can ask to the industry use the result of the production of the system. Yeah. But if we still use steam and electricity cogeneration or combined cycle, then the efficiency will increase. Yeah. Is it possible we can still increase the efficiency if we implement like a combined cycle or cogeneration? Yeah.
Yeah. In the case of waste incineration plant, maybe Anyway, the power generation efficiency of the incineration plant is not so high, so that's why it's better if we can utilize send all the steam into the neighboring factories. That efficiency is maximum, rather than the cogeneration. Yeah, in the case of thermal power plant, their power generation efficiency is high. That's why cogeneration becomes low. That can save energy, but if the power generation efficiency itself is low, in such a case, it's better to use the steam to the industrial process if there is much demand around the incineration plant. That is the situation.
Is there any question from the student or from Guntur maybe? Pak Guntur is
go ahead.
young lecturer, yeah.
Go ahead, I think.
Okay.
So.
Yeah. Okay. Okay. Thank you very much. Professor Fujii, because of Remi-san is already ready for this, and I think in the end of the class we will provide certificate for thank you for both of you. Yeah. Maybe after Remi-san. Yeah.
Okay. Thank you.
Okay. Thank you very much. Yeah.
Thank you very much.
And Remi-san, you can share your screen from
Yes.
your.
Okay. Can you hear me, Ratna-san?
Yeah, I can hear. And how about the student? Can you hear?
Clearly, Pak.
Okay, clear. Yeah. Okay.
Okay, it's clear. Okay, good. Thanks. So let me try to get the presentation now. Okay, please give me a minute. I will just extract this file. You can see the screen, right?
Yeah, we can see the.
Okay.
Okay.
So today I would like to talk about monitoring plastic waste, the opportunities and challenges. But first, I would like to give a short introduction of myself before that. My name is Remi Chandran, and I work with the Remote Sensing Technology Center of Japan. I was previously with Fujii-san at National Institute for Environment Studies, where we worked together on developing a monitoring and reporting verification system for addressing GHG emission in Bogor. And waste management was also one of our key areas. And I've also worked with several colleagues, especially Bapanas and Bapeda team as well in Indonesia on a waste management project we did for JICA for almost 10 years training program. And also, I'm very thankful to the wonderful partnership with Ratna-san and Uchok-san. It's been lovely that we have continued cooperation and one of the best knowledge bases in Indonesia as well. So thanks to both Ratna-san and Uchok-san for allowing me to give a short lecture here. And I will try to be very brief considering the time that we have. And also with me is my colleague, Ms. Pega. She's working with me. She's from University of Tokyo. Pega-san, do you want to give a short introduction of yourself?
Good morning. Is Pega, and I was graduated 1 year ago from Tokyo University. My specialty is more on the remote sensing of environment. Basically, we use remotely sensed satellite-based or airborne-based information to analyze the environmental changes, and probably if we can come up with a good result, we can go ahead with some policy measurement and policy regulation to control those changes and the negative impact of the anthropogenic activity.
Thank you.
And
Thank you.
Remi-san in Remote Sensing Technology Center of Japan.
Thanks very much, Pega-san. So Pega-san and myself are working on a very interesting project for developing a tool for monitoring plastic waste. And also with Fujii-san, we have put a proposal together with the Alliance to End Plastic Waste as well. So basically, we are developing a tool to make sure that we have an integrated mechanism for monitoring plastic waste. In addition, I also work with the World Bank on a solid waste management monitoring project in Colombia. And also I'm advisor for the Wildlife Enforcement Monitoring System project, which I myself developed while I was with the UN. So now coming back to the presentation, first want to give you an overview about the plastic waste being mismanaged. So if you look at the presentation, if you look at the map here, you can see in kilograms how much amount of plastic waste is being generated as well as going as waste. And if you look at the map, you can see that the southern hemisphere is one of the most highly affected region in the in general regarding all kinds of waste, but particularly plastic waste, in spite of the fact that the other parts are not, the southern hemisphere is not the major production zone, but it is one of the biggest consumption zone of plastic as well. So you have to understand the dynamics of the flow of plastics to before we monitoring. It is very important to understand the dynamics of the flow of plastic and plastic waste. So you can see here in India, Indonesia, especially the Java Island, and India is again a major source as well. And China, of course, China was one of the importer of waste as well, but now they've reduced. But now it has moved to certain countries like Thailand, Vietnam, and other Southeast Asian countries as well. In addition, Africa is also very seriously affected by plastic waste. You can see the Central Africa region as well. So is the Eastern Africa, Southern Africa region as well. That is very highly affected. Now, the problem of plastic is the biggest impact of plastic is known in the marine environment. And that is one of the interesting fact that the awareness of plastic came into the whole system when the marine wildlife became affected. And you can see a very interesting picture here about plastic waste. This is, I think, from Indonesia itself, from one of those sites in Indonesia, which is, it's a bit unfortunate, but you can see how people dump plastic waste into all kinds of waste, but particularly plastic waste into the rivers, which comes from a practice of open dumping. And this is not just in Indonesia, but it's all over the world, and especially in Asian region, where they consume a lot of plastic as short food material, or plastic bags, or even plastic bottles, and it's supply after use they throw it in the open areas. So one of the biggest challenge has been waste management system in many parts of the world. In Japan is very different. Japan, Germany, or European countries are very different when it comes to waste management. You can see that they have a very, as Fujii-san might have mentioned already, has a very systematic approach to waste management. They have a sorting mechanism which is start from home, and it moves into the mainstream, into the collection point, disposal, and recycling. But such a mechanism is missing in many parts of the developing world. And this is one of the reasons for the pollution of plastic waste as well. Now, another factor about plastic, the difference between plastic and other waste is the lifetime of that waste. If you look at municipal solid waste like garbage or paper or wood waste or debris, it can actually get into the environment without actually disintegrate, and it can be part of the environment. Whereas plastic cannot be. Plastic takes 400 to 500 to 5,000 years, according to researchers, to actually integrate. But its production cycle is very short. You can produce a large amount of plastics, and its use is also very short. That means you produce large amount of plastic, you use it for a very short time, and then you dump it into the environment, and it stays in the environment for 500 to 5,000 years. So that means you're accumulating large amount of plastic in a time period that it doesn't disintegrate. And this is a major problem. This is one of the concerns that the global bodies like the UN has. And that's how they come up with a measure to address the plastic problem. So it is actually a steady and potentially catastrophic burden of plastic flow into the Earth life support system. So again, you can see a little of stats. This is from the world data or world in data. And you can see the flow of plastic, the production of plastic. the global primary plastic production is 270 million tons. Whereas, and then its use and its it accumulates directly into the ocean. That means what is produced, it doesn't disintegrate as well unless it is recycled. So this is again a big concern that we have to look into as well. And most of them end in the marine environment, which is the biggest problem, which I think many of you know already, how much it is affecting the marine environment. And here I'm giving you a graph of the production of the million tons of plastic produced every year, and the different environmental conventions we have in spite of the production. We have starting from the Rio Agreement, or before that, even the Rio Agreement, we have the Stockholm Convention in 1972, and then we have the MARPOL Annex 5 in 1978. But all those agreements were there, but it never regulated plastic as of today. There was no measure on reducing plastic waste. Though the concept of circular economy was very much built into the Basel Convention, the issue of plastic was not seriously taken as much as it was done for the electronic waste or municipal solid waste or other waste, actually. So this is something that we have to consider in mind, that there were no measures to control plastic waste until recently. So now we are rushing to start with the process to reduce the consumption of plastic as soon as possible, because as I mentioned earlier, it doesn't disintegrate. We have to only recycle it. And there's tons of plastic produced every day. Unless we reduce our consumption, there is no way that we can manage the problem. And next, I want to make sure is when you're looking into monitoring systems, we always look at the agent. What is the primary agent of transport? And it seems for several researchers have were conducted, and it seems water, is one of the primary agent of plastic waste. Whether it is into, it's actually starting from a heavy downpour in the land, washing off the plastic from the land to the rivers, and then rivers contribute to the ocean. So it seems, according to statistics, 20 top ranking rivers contribute 67 of the top 10 plastic waste in the marine environment. That is only 20 rivers all over the world. And this accounts for roughly 90% of the global riverborne load of plastic. So if we can manage the flow, if we can manage the flow of plastic from the land to the river or into any water bodies, I think we can bring a good control. Hence, for this, we need a very good observation system. We need a very good land-based observation system before it enters the river. And the visible evidence of plastic waste, probably it is very hard to define the problem of plastic waste in land, because we don't see it, we only see it as a litter. But when it comes to the marine environment, you can see that, as you see in the picture, the marine environment is very much polluted by plastic waste as well. So you can see from whales to turtles and many other fishes and other bodies as well. And there's another big danger of microplastics getting into the fish environment, which then enters into our body as well. So the danger actually comes into when it enters the water, mainly when it enters the water, and when it goes into the biotic life cycle as well. So in Remote Sensing Technology Center, myself and Pegason actually work on a very interesting question now, how to address this issue of plastic using remote sensing technology. We're using several ways we're thinking, we are trying to innovate, but there are still so many challenges that we face because the current requirement of remote sensing technology is not so much fit to monitoring plastic waste. So one of the reasons is many of the plastic items, of course, we can monitor big debris, large plastics waste or large debris. But most of the plastic items are very small, which are difficult to monitor. And then once it enters the ocean, it is further difficult to monitor using remote sensing data because it is it cannot be captured in the existing space platform. I'm talking about plastic bottles and other things which are really, really small. And so we don't, even if you use high resolution systems, it is very hard to differentiate water covered plastics from surrounding water as well. So this is something that we have to bear in mind in our conclusion, in our research as well. Then for sea bottom monitoring, we cannot, I don't know whether we could use remote sensing data, so no one has ever done it before. And probably we could only use it by using probably underwater unmanned submarine or manned submarines, for example, small ones to monitor and collect samples. But this is something that is costly and it requires a large amount of investment, which I think many countries in the developing world will face a big challenge. So it has to be done through international cooperation. But I think there's a good amount of work that's currently going on to monitor the sea bottom plastic using unmanned vehicles. So that's one idea that we can even consider in our research as well. And then there are several other mechanisms also, which are like soft instruments. We call the GEO initiative, which is for the Global Earth Observation Systems, which is a network of among geospatial scientists and organizations from all over the world. And they have developed the initiative called the Ocean Sense Society Blue Planet Initiative in the development of indicators for marine plastic monitoring. And it's very interesting that they first go with the deposition. The deposition means we look at first where the plastic is deposited, whether it is a debris washed in the beaches, is it the shoreline, or is it in the beaches? And the other is whether it's in the water column, means you're looking at a transported material, whether it is in the sea flow, and the third is whether it is in already which has reached the animal life. And based on these 4 indicators, you can classify the amount of plastic that has been polluted. For example, if you're just finding it on the seashore and not in much on the deposit, means it is not a serious problem as it was thought. But whereas if you see it in the water column, and as you see in the picture that I showed earlier, like a large amount of plastic waste floating in the river, then you have a problem. And then when you have it in the seabed, it is a more serious problem, which means it is deposited already in the seabed. And then when it goes into biota, which is like turtles or birds or whales, other things have it, then you are having the chance of getting microplastics into your body as well. So this is something that we have to always consider also while in the monitoring research. So it is important that we look at when we choose a site for monitoring, it is always important to see the source where it is the surface between land and water, because most of the plastic comes from land and we need to find a way to stop it at the land surface itself. So monitoring the mouth of rivers and estuaries should be the primary target. The second thing is, even if we have controlled that, there is another problem that we are facing. A large volume of plastic also comes from shipping, fishing, mining, etc. So this goes, this is a pollution that happens right in the sea, where people actually deposit it right from the directly into the ocean. So this is again something that has to be monitored as well. And another big problem, as you see, it was happened in Japan recently. You can see the coastal disasters, for example, there is a tsunami or other things like a typhoon or hurricane which comes in, puts in a lot of waste, plastic waste into the river. So we need to have a mechanism to monitor the flow of debris into the river during huge catastrophes such as natural disasters like typhoon and other issues as well. So this is another point that we need to keep in mind while monitoring. Please tell me, am I clear? Is it the lecture? Can you hear me? It's very quiet. Ratna-san? Hello? Reza, can you hear me?
Remi-san, your voice is clear to me.
Okay. Okay, I go ahead then.
Yes, clear.
Okay, thank you. Yes, so I'm sorry, I'm talking in a very low voice because I'm talking from my office desk. Okay, I go ahead. So another study, actually, it's interesting. Well, some studies actually reveal a very interesting research which say that you have to switch off the, okay. Yeah, so a very, as I mentioned earlier, there is a very big flow of plastic into the ocean directly from the marine, from the shipping environment. And you can see that the researchers have found that fishing gears account for 46% of the plastic currently in the ocean. This is a surprise for me, but that's a research paper which came out, and I thought I should I should show it here. It comes from fishing. Around 46% of the plastic currently in the ocean are from fishing gears. And considering use, and the second biggest cause is the coastal disasters, which is, as I mentioned earlier, the flow of large typhoon or tsunami or something like that, taking or even a heavy rain downpour can actually make this flow of, take the plastic from the land straight into the rivers and into the ocean. So it's interesting that the two causes are mainly this direct pollution into the marine environment by the fishing or the shipping industries, and the second is the coastal disasters. But we have to bear in mind these two factors when we monitor the plastic waste. So the best way to move forward as an objective for plastic waste is prevention. So if we can prevent a lot of plastic entering into the waste system, that itself is a big measure. And I think that is something that is done very well in Japan, Singapore also, and even in Germany. So that is a very effective way of prevention, is one of the best way that you can see. They say that you don't let the plastic touch the soil. So you basically take it and then either recycle to recycle containers, or you have a payment system where you have you pay the people who bring back the plastic bottles, something like that, where we actually do a prevention measure as well. And the second thing is we need to have infrastructure and systems for waste management, for material recycling, for land-based activities in a particular country. This is not happening in many countries. For example, in Japan, there is a very good record of how much waste is generated, how much it is collected, where it goes, and it's very well monitored, including with GPS. But in the case of many other countries, they don't have it. And because waste is not something that is a priority for governments in many countries. So that is the reason why it is not having an infrastructure for monitoring waste as well. Even because I know I'm working with Colombia now for developing a system for waste management. And it seems in Colombia also they have several problems like we see in any other developing country. And you can see that the few major cities have some kind of mechanism, but the rest of the places do not have anything. But the flow of plastic or other waste comes from different parts of the world into the rivers, and the river actually flows into the ocean from the rural areas. So that we have to always consider in mind of having systems not just in developed part, but also in rural areas, because the origin of the moment of water starts from the rural areas, actually. So the ocean, the catchment is always in the beginning is always in the rural area. So any open dumping that takes place at the high end of the catchment will definitely lead to a very high pollution, even if there is a very good waste management mechanism at the city level, which is usually close to the coastal areas. And then the third one is, of course, we need to have global commitments and national region instrument. It's already there, but I think there should be more emphasis on the requirement of coming up together as a joint effort to reduce plastic waste. For example, there is a lot of plastic being exported, waste plastic or waste being exported. China was one of the sources. Now China has stopped. Now it is moving to other regions. Some are moving illegally as well. So there has to be some way to control this mechanism to reduce the plastic waste as well. So myself, as I mentioned, we are working also with Fujii-san on this matter, and we are using a two-way approach. One is we are coupling the management aspect, which Fujii-san might have already mentioned about the closed loop method, which we could use, and a monitoring mechanism, which we support as well. So we use base map, which is, as we say, from the beginning of we are using the land use map, and we're using high resolution data sets also to identify every point of pollution. I don't say that we are monitoring the plastic, but we are trying to see the location or the source of high and potential sites which can lead to high plastic volume or plastic waste, which can be a convenience store or a supermarket or a household where there's no, in case of where there's no waste management mechanism, so or hotels or something, some business activity which generates plastic. So we use the land use to actually identify these spots which are the source of this plastic, but we are not monitoring plastic as such, but we are using the source. And from the source, then we move into the next part, which is called ground-based monitoring, using either we can use like crowdsource, like people taking pictures and photographs and using. And then we can also use land use change patterns, which if there is some construction going on and if there's construction waste taking place and other things as well that we can also monitor. But we are in the early process, so we have not defined a very earliest defined clear structure yet. But I think this is something that we are working along with Fujii-san on this matter for the Alliance for End Plastic Waste. And we hope that we could have this kind of one is a measure to support to address the problem, as well as a monitoring tool to actually monitor the end-to-end of a plastic, origin of plastic to the end of the plastic, so end-to-end process as well through a monitoring mechanism. And we use and visualize it using a GIP tool, which is a geoinformation platform, which would be, I think, Fujii-san, you have already. Fujii-san, are you there?
Oh, yes.
You've already mentioned, I think, about the GIP tool in the.
Not so. Yeah, very, very. I can say. Yeah.
Okay. Okay. So. Wait. Yes. So this is so we are trying to. Myself and Pegasan are now working on this issue, but we are also trying to see how we could use crowdsourced tools. For example, have some indicators of tools to actually report about plastic. One is about impact, the other is about the waste itself, being people in platform. Thinking about a tool that can bring out such a mechanism as well. So as I mentioned earlier, the direct impact of plastic waste is always on the wildlife or the fishing, especially the marine environment. And that can also be monitored. So, and second thing is there is a large volume of data available, so which we have to do a kind of data mining. So kind of big data analysis should be used to extract observation from social media, press, or published literature. And the third mechanism, which I think, which I got looking into a research paper actually. So Pegasan, sorry, this may be new to you. So tagging susceptible bird species and tracking for potential interaction with marine litter. Because birds are also very highly susceptible to plastic waste. Probably you can see that even a common crow would take a plastic and run away, but sometimes it gets into their body also. And there's other mammals also, whales and water mammals also, at the risk of digest plastic, which we can also do as well. So we are using kind of monitoring the land pollution as well as the marine and the biotic pollution mechanism. And somehow we put it all into one track of the system. So this is something that we can use not only to track the flow of plastic, but also to find the impact of plastic, harmful impact of plastic waste. Because governments are more interested in the social systems, how it is affecting social systems. So these a tool should always not only track the chemical or material flow, but also track the impact on the social side as well. So I think this would be also important for governments to get them interested in addressing the problem. So we think that combining the different systems would actually help with the a clear monitoring of the plastic waste. And this is this model is actually designed by Pegasan. And Pegasan, do you want to give a short explanation about the process we are trying to do?
So actually, to make it more clear, the model, the main body of model was not designed by us. Actually, it was adopted from recently published paper that I've been, the citation is already there. So if you're interested, you can go and check. But basically, the steps that we need to have is that, as Remi mentioned earlier, one of the most important component for monitoring the plastic and marine plastic basically is to have a good amount and in terms of quality and quantity of field data and observation data. Otherwise, we might not be able to assure the quality of remote sensing observation. So basically, based on the same logic, at the first step of this model, we suggest to have kind of field campaign to collect information, either dynamic data or static data. For example, we could have some information about the population of the city, the population density, about the land use and land cover. Basically, the main step is to try to collect the information as much as is possible to identify the hotspot, the most probable places that would probably have some leakage of plastic and debris to marine environment. Having that information in the second step, we send the second kind of theme of the field observer to go and check the specifically marine plastic debris and collect. This part has been cited, so you can go and read the detail in their paper, which was really, comprehensive. But basically, in this part, people go to those hotspots, collect information, and in terms of plastic, the characteristics of the water body, and combining those information with satellites information and some hydrological model, we hopefully will be able to track the plastic and debris movement until they come to the ocean side. And the third step that we hope we can do is to propose kind of web-based and model application where you can have a twofold usage. You can also put the information as an observer of plastic debris, or you can also see and observe how would be the flow and how would be the characteristic of the plastic movement, basically marine debris movement in a river inside the city or in an ocean. That's probably the biggest goal. This is from me. If you need, or if any part is unclear, please let me know and elaborate.
Okay, thank you, Pekasan. Thanks for the very, very nice way of explaining the model. And as you said, we are now working on this new model and see how we could develop it. And probably we may, with Fujii-san, we will be able to implement it probably in South Sumatra region if everything goes well. And we could expand it to other regions in Indonesia as well. Probably, but we have to consider the river dynamics and things like that. Probably the river that we're choosing is a Musirawas in Sumatra. So we will identify that part and study that region and try to apply this model. Okay, moving on. I think this is the processing flow of identifying plastic waste leakage hotspots. Probably because this is again your end that we have to machine. But I think I can. Do you want to explain? Do you want to explain?
Basically, this is the same concept that we collect different layer of information about the city, like the population, about the land use, land cover, and any other supportive ancillary data, together with data collection, field data collection, and we use them with multiple other sorts of remotely sensed data to identify the high potential spots for leakage of the plastic to the environment and basically riverian or ocean-based pollution. So again, same concept.
Yes. So here we use, as we earlier mentioned, machine learning and big data to identify the hotspots as well. I think I also mentioned in the beginning of the lecture about this as well. And the next part, I think time is limited, so I just quickly move to the our other area. But this is again an conceptual approach, which we explained earlier itself, how we are identifying it. We also look into the hydrological models that have been developed, and from that we will extract and move into the identify the flow of the riverine plastic waste. As for the database, we may use, I don't know how much you're familiar with remote sensing data, but we are planning to use several data sets for our work. I think, but to give you an overview, we use even how do you say, very high resolution data sets, including AW3D and MODIS, GCOM, etc., which is, and we can also combine it with some of the supporting data as well. So you have to also understand one of the challenges in using such a mechanism also. Remote sensing data application is also very much related to the confidentiality agreement also. So we may have to see how much we can monitor using the data as well. So of course, there's a common agreement on the government side also to approve such a monitoring. So that part is also very critical and very important as well. And of course, we will have all to have, as Pegasan earlier mentioned, to have a very good model, we need to have ground data. And as I mentioned, in the case of Japan, they have very good statistical data. But we should have a similar statistical data in Indonesia as well to start such a project in Indonesia. So because the ground data is very important because the ground data is so important in the verification mechanism. So the statistical, social, economical data, everything counts as well, yes. And of course, monitoring the waste management also requires local habit, policy, regulation, infrastructure, etc. as well, that we have to count into the system, into the database as well. Sorry, the diagram is not so clear. Just trying to bring it from another colleague of mine. And so these are some of the things that are already there in the case of Japan, which I think we could think about a similar one in the case of Indonesia or other regions as well, which include, for example, a waste app for registering a waste location by resident. This is what I mentioned earlier. We can use mobile phone to track the movement of the waste as well and collect the waste and even identify what kind of waste, whether it's a plastic or whether it's a other kind of waste also. And there are even in Japan, there is even Fujii, please correct me if I'm wrong, but I think we have a GPS-based trucks in Japan where you can actually see the moment of transportation of waste and how it is movement also, and how much waste is collected. Perhaps this is also something that we have to restart with the case of plastics as well. Probably there should be a way to classify plastic waste right from the home, as it's done in Japan. So this is something that we need to look into as well. And based on that, we can, as water is the primary source of marine plastic waste, as I mentioned, the weather condition, heavy rain or a typhoon or a tsunami or anything that causes a disaster can actually carry the load to the river or and further to the ocean. So the weather forecast is also a very critical data important, and for that we could, there are various forecasting mechanism also using remote sensing technology as well. And then, of course, we need a prediction of waste volume based on demographic area, infrastructure, transportation, etc. So these are all in the tool that we are trying to develop as well. And here is a very simple tool that was developed by ESRI. And this is to capture the plastic waste in kind of waste that has been generated. And it is based on your mobile phone. So you could use this tool from your mobile phone to actually identify what kind of waste it is and how it can be tracked as well. So there are existing tools which gives you, we don't have to reinvent the wheel. There's already so many tools that you can use to actually record the waste as well. The only thing is the recorded waste should be somehow verified, and then it should come to a central database. And this central database then visualizes and give a picture about the high volume of waste that are given. It's because I mentioned primarily the hotspots of plastic waste generation. And then another part that we need to do also is database development and tool development are good enough, but it will not be good if it's not used very well. So in most of if you look at the information system side, there's a lot of development in the information system side, but the application and the use of the system has been always on the back end, especially when it comes to government usage of systems. So we have to make sure that the system, if developed, should be used and used properly. Otherwise, there's no point in developing a system and then just having it there. So we have to have continuous capacity development programs. And basically, you develop the system and you're seeing and monitoring the progress for every month, and having workshops to bring them together to address the challenges and to showcase study cases as well. So these are things that we have to consider as well in our work as well. And this is, as was mentioned, there's also important observation of river watershed using optical data that we can do using remote sensing. So maybe it is difficult to monitor plastic using remote sensing later, but at least the source of plastics can be identified if we use the watershed atlas. So if you identify the source of the river mouth and the potential areas that can flood and that can cause movement of plastic into the rivers as well. So this would be another idea that we have to think about. There are already catchment models for most of the rivers. Major rivers have all been, because of flood monitoring, there are already very good catchment models. So we could use existing models to identify those. And then based on that, we integrate that with the current model to see if we can somehow bridge the two to find a way to address the problem. And finally, I just want to say that myself and Fujii-san and we have RESTEC and especially myself, Pega-san and Fujii-san and our colleagues here also working together to develop this integrated mechanism to address the plastic waste problem in Asia. So if you're interested, if any students are interested, or of course we are working with Ratna-san and Chok-san as well. And if any students are interested to join hands, we are most welcome. And you can contact me by email, or you can contact Pega-san. I didn't put email, but I think you can contact me or Pega-san through my email as well. And we are most happy to help you on this matter as well. So thank you. So I think this is my final presentation for the lecture. If you have any questions, please.
Thank you very much, Remi-san. And how about the student? Is there any question about the implementation or planning to use this model for identify the transportation of the waste plastic, even not only for through the river, but also bring by other transport tools. For example, people bring the plastic waste to another place, and then maybe by truck, maybe by scavenger. Yeah,
that's right.
Okay, how about the student? because the student can collaborate with this
Yes.
the team, to strengthen the information, particularly database for the plastic waste itself.
Absolutely. I think we can develop a network of students who are interested and probably identify a location. We could start with a very probably a small area, which I think which Fujii-san probably I would work with also Fujii-san on this matter. And we use this location and then try to gather some data from this area and try to find a solution. I think this would be a good step as well, as Ratan, so you mentioned rightly. Yes.
Yeah.
So not only through river, but also through the terrestrial transport mechanism as well.
Yeah.
Usually, large volume of dumping also takes place here and there, so that we have to take into consideration also.
And how about if the student want to contribute with this information? What kind of data? Is it only in one place there is a plastic sources, and then how to bring the plastic source to industry or to a dump site?
Yes, I think that would be a very, first of all, how we could have a discussion on how we can develop kind of a network mechanism for this. Probably we could have a tool in place, and from the tool, we can start the students to actually add those data into the tool. And then we could do an analysis and see the first mechanism, first kind of approach, how the results come out. So we can use, now we can use different data sets, which are the remote sensing data sets I'm talking. Then we have the ground monitoring mechanism, which is done by the students. So integrating these two, it will be a good approach. We can start with a very small way. I think Fujii-san, do you have any ideas as well?
Yes. Yeah, your idea is okay, fine.
Yeah, so I think that would be a very, very, very good way to actually start with that.
Yeah, because of sometimes the waste directly to industry, yeah, and
right.
through the scavenger there is long way to go to the industry as well as to the recycle, maybe because of from the scavenger bring to another place, and then finally to industry. Yeah, maybe there are 3 or 5 steps. Yeah.
Yes, absolutely. Yeah, so I think this would be very important to actually identify the different steps that the flow takes place, and we need to know whether there is a sorting. So it goes into open dump area, and then from landfill site, and from the landfill site they actually do the sorting. Is that what happens? I guess in many places, isn't it?
Okay. Yeah. And is there any question from the student or from another attendants like Guntur or our research center staff? Yeah. Hello.
Yes, Bu. Maybe I have one question regarding this modeling, because I think this is very interesting. Yeah? I mean, like an approach to fight plastic pollution by using modeling. It is somewhat interesting because I'm also working on it, but not about plastic waste, but regarding river quality. My question is actually how actually this is some of my friend from Surabaya also working on it, and this is the same question: how do you collect the data? Because collecting the database to build the model, I think it is the hardest one, and my college also face the same problem. So is there any kind of means to get the database, and then how do you connect the database and the model that you create into let's say a direct solution, like maybe a regulation or maybe some kind of technology or something like that? I think that's all my question.
Yes, I think there are several tools for data collection. But I think we could, as I mentioned earlier, it's a very dispersed problem when it comes to plastic. It's almost everywhere. So it is unlike in many other situations. We cannot. It's actually random and it's very everywhere. So as you rightly mentioned, it's one of the difficult tasks of how you collect this random data from all over the world, all over the places. So only way we could do it is to identify the hotspots. And hotspots means the areas which actually are located, which are source of major plastic pollution. I'll give you an example. One is in convenience stores. In most of the convenience stores are the generation of plastic waste because the people buy a lot of short food, quick food and fast food stuffs, and they use plastic wrappers or even plastic spoons. And things are changing a bit now. And then once that is finished, they just throw it away. Either it is thrown in a bin or it's just dumped in nearby places. But the center, that location where the convenience store remains is the center of a hotspot because it is a spot where lots of plastic is being used. Whether it goes into the right place or into the wrong place, it has to be done by the monitoring mechanism. So that's why we have to have a way to monitor it. And the only way you could do it is by social media or through public actually reporting mechanism. So this is something that we need to think about, innovative way of identifying. For example, if it's in Japan, or you have systematic collection process, the collectors himself report it. Can we do it in the case of Indonesia, where we can give such tools to the waste collectors, and waste collectors themselves report about such an issue? So this is something that we need to consider. And second thing is, we could even have it as an app in the mobile phones to people to randomly report about plastic waste. So this is something that an app would be used only if government also comes into play. So especially comes to people behavior. So then we need to have something that can actually that we have to think about how we move forward with the plan of action. I think there are two ways of doing. One is the waste collectors themselves, as Ratna sir mentioned earlier. We can identify the track the route, and the second thing is to the public, and we use as a tool or through social media to identify such a waste as well. Also, Pegasan, if you have any ideas or thoughts, please add in.
I guess what you said, Reni-san, was enough comprehensive. I get the reason that we propose to have hotspot identification. The fact is, data collection is really labor intensive and its cost is quite high. So we cannot expect to conduct a field survey and data collection for every. Might be some linkage. So the first step, I believe, to make it more efficient is to identify the most probable leakage spot, so that we send the campaign team over there to collect the data. But then it comes to the standard and uniform data collection, which I was trying to find a paper. I forgot the name of the first author, but there's actually very good paper that they suggest very uniform way of marine plastic and marine debris data collection, so that all the teams can use the same methodology and same kind of indexes to have the field observation. So these two are, I guess, the main important factors for the field observation that comes to my mind.
Okay, thank you, Pegasan.
Thank you very much.
Over to you, Ratna. Is there any other questions?
Is there any question from the student? Hello, yeah. because of the time is already 10 o'clock, maybe one question from the student. If there is no question, I think because it's already 10 o'clock, we can still have a discussion between us and also Pak Guntur and also the team from our research center. But for students, because of yeah, maybe the student have another class, yeah. And I think I want to close this class first. And then before closing the class, I would like to give a certificate to Professor Fujii as well as for Remi Chandran for give important information for the class. And maybe from is there Pak Chandra from Guntur? Pak Chandra ada nggak ya Guntur ya?
Pak Chandra ada rapat.
Oh masih ada rapat ya? Oke, dari kita aja ya Guntur ya.
Saya juga ada rapat jam 10.
Oh iya, udah kita mau sharing tentang ini sertifikatnya. Thank you Professor Fujii and also Remi Chandran for giving the lecture. And this is the certificate. One certificate is come from Chemical Engineering Department, Faculty of Industrial Technology, for both of you, for Professor Fujii as well as for Remi Chandran. And another certificate is come from our research center because of our research center also attend this meeting as well, our staff. Yeah. So also important for us to have a elaboration about the research itself. Yeah. And there are two certificates. Yeah. Okay, I will send it by email later. And this is the certificate. Yeah. Thank you very much. Yeah.
Thank you very much, Ratan-san.